Hi everyone. Thank you for joining us today and welcome to our simulation Moldflow IQ. Today we are with a topic about introduction in Moldflow Adviser 2016. Myself, Javier Jubierre. I'm working as a technical support in our office in Munich. I hold a master's degree in mechanical engineering and a second one in computational mechanics. Define myself like a runner and rider, so I'm usually training for half distance, let's say half marathon, running like this. If not, I like also in summer to ride with my motorbike. And today, Kristen Kilroy is going to join us. So, Kristen, do you want to present yourself?
Thanks, Javier. Sure. As many of you know, I'm also on the technical support team for Moldflow products at Autodesk. I've been here probably about 2.5 years now, so I've dealt with the majority of you if you've ever reached out to the support team. I have a degree in plastics engineering technology from Pennsylvania State University, and just to go along with the hobbies that Javier presented, whenever it's warm out, not right now because it's a little cold, but on warmer days I like to go kayaking or hiking through the mountains up here in New Hampshire. So I'll turn it back over to Javier and he can get us started with the webinar.
Yeah, cool. So thank you. So let's go ahead. So just remember, like all our webinars, in your webinar application you have the field to make us questions. We have 3 colleagues behind the scenes, Paul, James, and Jay. Probably you already talked to them for other cases. They will answer your questions, and if they find that this question could be interesting for everybody, they will put it here in common and we could discuss it in a group. Okay, so the slides of this presentation will be after our webinar, placed on our box, and you could just download it following the link was in the previous slide. Some additional information. So we are preparing for an upcoming webinar, first introduction in the API with Insight. So probably some of you already take a look on the information we have in the Autodesk University. Last November was 2 lectures of the 2 classes going this direction. So, but we are preparing a small webinar where we are going to touch this point. From our past webinars, we talk about, for example, how to establish, how to run DOEs, how to match simulation with reality. All these webinars are already recorded like this one, and you could reach it through our channel in YouTube. So our channel, Autodesk Sim 360, and then you go inside to Moldflow IQ. So if you get the invitation for this webinar through a colleague of you and you want to get this email directly, so that's pretty simple. You could go to our forums for Autodesk simulation, for Autodesk Moldflow. You could go directly to our main website, autodesk.com, help webinars. You could do it through the Sim Hub events, or just send us an email and we will put you in this distribution list. So, Kristen, could you go to the next slide? Thank you. So, as you know, probably you're actually making us questions because of whatever doubts or problems you are running with Moldflow. So we are collecting all this information and placing in our Autodesk Knowledge Network. We are publishing some articles. Just feel free to go there and to take a look on the last articles we wrote, we publish, or if you have any question that you don't understand how Moldflow is working, you could also go there and try to find a first answer. Another thing we get from development is that when Moldflow is crashing, time to time it's also happening. So there's the possibility of sending these automatic reports. What we are seeing is that the 40% of these automatic reports after crashing of Moldflow could be fixed just keeping updated Moldflow with the last service pack. So please, if you don't have it yet, go to our website, download the last service pack. We already released the third service pack. Install it because this will make Moldflow much more smoother. And with this, I will give the word to Kristen, and we will start actually with the webinar today.
Thanks, Javier. And just to reiterate what he mentioned earlier, this will be available, this whole presentation will be available through YouTube channel. So once this is finished, we'll do a couple quick edits to it and then upload it to the web or YouTube channel for you to share it to your colleagues or just watch in the future as a reference. And to go into the topics of today, we basically wanted to go over a quick demonstration of Moldflow Adviser. So it's fairly basic. If you're more of an advanced user, this might be a little too basic for you, but always feel free to sit in on this, and we're happy to hopefully show you some new tips and tricks along the way. So we'll be covering the analysis sequences throughout Moldflow Adviser, as well as how to set up a tool using the analysis wizard. And we'll go over a few results here and show you how to get the best out of your experience with Adviser. And as I mentioned, throughout the whole presentation, we'll do some tips and tricks, either through demos or just mention it during the slideshow. But we also just put a cheat sheet at the end of this presentation for you in the future. Okay, so Moldflow, if you're not too familiar with the product, it contains, or there are three options for licensing: a standard, premium, and ultimate. This is the same with Moldflow Adviser as it is with our other products, Synergy and Insight. And basically what this is it's controlling the types of analyses that you're able to run within Moldflow. So in this case, for standard, all the analyses are kind of based around the part optimization. And then for premium, you're getting a little bit more complex, going into optimizing the runner and mold designs. And then finally, with the ultimate license, you're actually going to get a little more features there, going into mold and analyzing cooling circuits. And you'll also be able to use packing and warpage analysis as well. And to the right there, I listed a couple links that actually go into some of our comparison websites. So the top one there is just the help files that list all the analysis types and which one is able to be run using those licenses. And then the bottom one there, the Compare Moldflow Products, actually takes you in and you can compare different features within the different licenses, and it's an interactive comparison chart. So you can even bring in Moldflow Insight and Synergy in there as well. As mentioned, you can run a whole bunch of different types of analyses within Moldflow Adviser. Here's a list of the ones that are available, and say for Moldflow Ultimate license, you would be able to run all of these in there. Now, if you're not sure which analysis type you would, or which license you would need for the analysis, typically it'll list it whenever you click it in the analysis wizard. It'll show something similar to that picture there where it says fill a pack analysis needs an ultimate module to run. And this is a nice way to keep track of, oh, you might need that license in the future if you're looking to expand your capabilities. So you can take a look at that and determine which one you might need. Now moving into the meshing of Advisor, some people get a little confused by it because it's a little bit different from other FEA programs. The Moldflow Adviser doesn't actually show the mesh on the part. It's kind of hidden in the background for the solvers to look at. So once you import the part, you're able to actually control whether you want it dual domain or 3D. But it also gives a little box up there that shows advice, and the solvers kind of look at things such as the thickness of the part or complexity of geometry and recommend if it should be used for dual domain or 3D analysis. Now you can change that. It just gives that recommendation there. Typically you're okay going with that recommendation. Sometimes if you want a little bit more detail, you might want to switch over to the 3D if it recommends the dual domain. Now moving on to setting up the actual tool in Moldflow. What there are three options. One for adjust the part, and then two more options for single cavity and multi-cavity. Now, whenever you're going through to actually create that mold, you actually have to do a couple different steps here, and I just listed out some steps, and basically you just want to follow that ribbon in the interface. So first thing you would want to do is set your analysis type. Plan for what kind of results you want to get. Do you want to run a fill analysis only? You're only interested in if the part will fill? Or do you want to go into a warp analysis where you're actually looking at how it's going to warp compared to the process settings that you're going to put in? And one thing that we often see in support is customers complaining they're not able to select certain options in that tab. So if something's grayed out that you want to add to your model, try those three steps here. Is it a part, or is it set to part only? Are you trying to, or do you have an injection cone added? If not, see if there's a parting plane there. And typically after you add these components to it, or change it from part only to multi-cavity or single cavity, you're going to be able to select the other options in that tab. Now, a key thing that we often see in support also is orientation of the part. Whenever you import a model, it's key to take a look at it and make sure it's oriented on the XY plane for the clamp force calculation to properly calculate it. And it looks at the surface area almost like the shadow of that shape on that plane to calculate the area there. The parting lane itself determines the end of the gate. So sometimes you want to move it up. Sometimes you want it a little bit down below that initial injection point. And that can be done by using that red box there shown on the right. And when creating the mold itself, you're able to use those red boxes again to kind of drag and drop pretty user-friendly in there. Or you can use the actual coordinates, and we'll go into a quick demo in a few slides here. So with regards to the feed and cool system, you can use either wizards, draw it manually, or else import the components. Whenever you use the wizard, basically you just go in and specify what kind of runner do you want, what kind of gate do you want. And you can also specify the position of the sprue. After that, you just click apply and it will automatically draw that runner system for you on the part or parts that you have. Whenever you go to draw it manually, one thing to keep in mind is use that grid pattern to help kind of direct you to where you want to draw that runner. You can add options such as snap to grid, snap to runner, or auto connect to the next runner, and this will help it to be more user-friendly to creating that runner for you. And finally, when you're importing the component, either a runner system or a cooling system, you want to look in the ribbon there, and you're going to actually have to expand it, so click on the word either feed system or cooling system, and that'll show the option for importing the runner or import the channels. And to be able to import either of these, you'll actually have to have the IGES curves from your CAD program. So basically, the center lines on your CAD model, export those as IGES, and you'll be able to import those into Moldflow. If you have trouble, you might have to switch a couple settings within your CAD program, but typically they should come in without any issues. Now, if you do that for the feed system, you're going to actually have to manually create the gate and the sprue after importing those. And this is just the way that Moldflow Adviser imports. It's not able to actually capture those gates and sprues because of the mold size that you assign to it. So adding them after manually gives you a little control and make sure it's getting to the correct positions. So with that, let me switch over to my Moldflow Adviser and run through a couple quick demos for you here. So let's go ahead and just start a quick project, have one open here, and import a part. And for this one, I'll just go and do one of the tutorial files. If you're not familiar with it, the tutorial files are listed under your installation drive under the C, Users, Public Documents, and then Autodesk. From there, it'll show the program, and you'll be able to select any of these preloaded studies in here. So let's just bring in the STL model here. And next. Here you can see units, switch those up if you want. I'll just keep those default. And it'll ask if you want it to automatically clean up or check suitability. Typically I leave those on because sometimes in the background whenever it's importing, it'll clean up the model so that you're not running into any issues after running the or starting the analysis. Sometimes it'll fail with geometry issues that could be caught with that automatic cleanup option. So we'll run through that import. And here you go. As I mentioned, it'll give me some advice here. It's recommended for dual domain analysis, but I have the option to switch it over. For now, I'll keep it on that dual domain one. Click Finish. And you can see there, part was imported. So from here, I'll go ahead up to the ribbon menu up here, and you can see that part only mold type listed here. And we'll go ahead and switch that over right now, just so we have that set up for us to kind of continue with that the rest of this demo here. I'll go ahead and add an injection location. And it's pretty nice. You can add as many as you want. You can delete them if you want. And now I'll go into kind of the main tab that you'll be working through in Adviser, the Geometry tab. And here, again, you can see you could switch it over if you decide to do that multi-cavity or switch back to the part only. But in this case, we'll keep it on single cavity, add that parting plane, and you can see it readjust the view so that you're able to see exactly what that parting line is lying on. So we'll move that right to the top of the part there and go ahead and close out of that. Select mold size here. And again, these red dots here allow you to drag and pull those as big as you want. We'll just do that. And let's say you have a set size for that B plate. So let's go over here to the coordinates and say, well, I don't know, let's go with 4 inches. Click Enter, and it assigns that as 4 inches. So you can see there it's pretty nice being able to either drag and drop, not really knowing the dimensions of it, just to get a feel for the size of the mold. You can reorient it, take a look at it, drag if you want a little bit longer. But I think that's good for right now, at least what we'll do today. All right, the next thing here, as you can see, we're just moving from the left to the right up here, the feed system. So I'll go ahead and add a gate. Some users do it a little bit differently. Method-wise, you might start with the sprue instead of the gate. I typically like working from the part and backwards. So I work with the gate, then the runner, then the sprue. So I'll create a quick gate here. You can see it automatically snaps to your injection location. Now if I had multiple injection locations here, it would, after I click apply, it would switch to the next one automatically, so you can go ahead and make any edits needed. So I'll go ahead and click on the properties here. So you can see create gate and cold rectangular. We'll keep that rectangular for now to make it a tab gate. And go ahead and click OK. And you can see you can define some coordinates here. I'll just leave everything default for now. And there we go. Just created a gate. Now the one thing that you might notice is sometimes these plates here get a little bit in the way of reviewing your model. So if, say, you wanted to hide these for now, you can go up to this View tab here, click Object Visibility, and uncheck the mold outline. So that kind of puts it in the background, out of view, out of sight. But it's still there once you do decide to do it, or you want to look at it. So I'll turn that back on just for now and switch back over to Geometry tab and add that runner. So here you can see there's our gate there, and it's a little bit on an angle because we pulled that parting plane up a bit, but I think we're going to be okay just for this demo purposes today. Now when you're creating a runner, typically I like to keep this snap to runner enabled here, because that way you're able to actually select that point. And that ensures connectivity between the part and the model of the runner system. So we'll go ahead and reorient this so it's a little bit easier. I think I clicked on the wrong one there, so let's try that again. There we go. So see how that little yellow dot there kind of selects there? If you click on that, you're able to adjust this around as much as you want. You can click on Snap to Grid and make any adjustments to the grid if you'd like, so change that around. But again, for this demo, I'll keep that the same here. And what I'll actually do is use a coordinate rather than just click any random place here. So to keep it kind of a straight runner, I'll go ahead in the positive Y direction. Let's say 2 inches. And if we zoom out, you can see, whoa, I make that a little bit long. If you want to undo it, you can, or if you wanted to make that mold a little bit longer here, you can go back, change that mold size by clicking mold size here, and just dragging it to the new position. Only thing with that is if we click on mold size here, sometimes it'll ask to delete the runner system. So this time, since it's only dragging the size of the mold here, there's not too much effect on that runner. But if we went to change the parting line, for instance, we'll just go here, it pops up with a message, do you want to invalidate the existing runner system? So what that would mean is, since that parting line was moved or changed, the existing parting line that was on it before is not really applicable for this runner system anymore. So if you click OK here, it would remove that runner. So we'll cancel out of that for now and close out of there. That way it's back to the original position. And we can see now we have some space for that sprue. Let's go ahead up here, add sprue. And again, you can enter in a specific coordinate. By default, it'll go to the center of the mold. You can even recenter it if you make any adjustments to it afterwards. Today, what I'm going to do is actually go in here and click on the end of the runner. And what that does is just sets the X and Y coordinates so that once you click apply, it'll apply that sprue to that position. Now, you can see there the default size for that sprue is a little large for this model here. So if you right-click, click Properties, or else click Properties up here, you're able to make any adjustments you need. So in this case, we'll take that size down, maybe do much smaller here, 0.6, see how that looks. And you can see here you can make as many changes as you want just by clicking Apply there. So we'll go ahead and keep that there. It's a little bit large for this model, but just for these purposes, we'll keep that. And as I mentioned in the PowerPoint, to import a runner system, if you didn't want to go through and create that manually, or else go through the runner wizard here, you can actually import that model by clicking Import Runners. And from there, you can get that IGES file from your CAD model. Okay, so with that, what I am going to do is switch back over to the PowerPoint now and go into the Analysis Wizard. Now, this is kind of where the bulk of the load is for making sure your analysis matches to process settings and materials and even the analysis sequence. So here you can see it's just listed with tabs up here that you can either sequence through with next. You can click the tabs at the top, or you can click finish on it, excuse me. If you click finish, it'll exit out of it, and you can go ahead into the menu bar in the ribbon and relaunch it at any time. So within that same analysis wizard, there's one tab that was recently added, I believe this release or the last release, I apologize, I forget which one, but basically it's for refining that mesh. So if you remember, I said earlier that the mesh in Moldflow is not visible, so you're not able to actually see the triangle or tetrahedral elements in it. This way, you're able to at least control that refinement. So if you have a geometry or a geometric feature that's very small or fine, you're able to increase that refinement to be able to capture it more accurately. Now, the one drawback is, as you increase that refinement, it does require more time to analyze, as well as resources needed to run that analysis. So keep that in mind if you're running through that. Sometimes it's okay to bump it 1-2 levels. Other times it could get into a much lengthier analysis time for that. Okay, so moving forward to results. One thing I wanted to bring up, I'm not going to go through each result and kind of explain it there, because I wanted to show you the resources for understanding those, just in case you want to go back to refer to in the future. So if you go in Moldflow Adviser, there's an option for dynamic help. This is a help screen that's on the user interface permanently, or you can disable it if it's in your way, that will actively jump to anything that you might be needing help with. So if you're looking at a certain result, it'll pop up with information about that result, as well as how to interpret it and what to look for in that result to maybe cause warning to your analysis. Alternately, you can go to the top right corner of the Moldflow interface to that little question mark, and that'll bring up the help pages for Moldflow Insight. And you can navigate through those at your own speed and pace and do any searches through there as well. That keyword box there is also nice to help doing an impromptu search, and all you do, go in there, type what you're looking for, say fill time result, and it'll pop up with the help files for that. Now, whenever you're reviewing results in Advisor, you can use tools like the tile, split, and lock tools to compare different results. So in this case, I used the split tool, which essentially splits your window into quadrants. And on here, I just put the fill time, injection pressure, weld lines, and deflection. So say you're looking to investigate those weld lines a little bit more, so you want that fill time result right above that. Or if you want to look at the deflection, to understand that a little bit further, you can use that fill time and injection pressure plot to kind of look into that a little bit further. And you're also able to control plot properties such as animation, scaling, and things like that. And we'll go into a brief demo on those as well. Now, the one thing that several users aren't really aware of is the summary. So whenever you finish an analysis, this will pop up on the bottom half of your screen. And basically, it's just describing the entire analysis. So in this case, you can see here a fill pack warp analysis was run. So there's a different tab for each of those analyses up at the top there. And you can sequence through each of those, and they show some information on it. So you can see the fill time, injection pressure, and clamp force, and the clamp force area especially. If you're noticing that your clamp force is way too low, you might have the part oriented improperly. So take a look at that clamp force area, or take a look at the orientation of the part within the user interface there, and you can kind of troubleshoot it back to there. And another thing that I wanted to point out there is at the bottom of the screen, you can see a box marked solver warnings. This box actually shows any errors or warning messages that might occur. So if you're short-shotting on your part, it'll pop up with a message there saying, warning, short shot. And the last thing I kind of wanted to go over briefly was the cost advisor. And Javier will be pulling up a demo portion of that in just a minute here. But I figured I'd kind of show you the screen here and let you know a little bit about it. So Cost Advisor is essentially a dialog in Moldflow that you can customize to kind of help predict the cost associated with molding the part, or how to differentiate with mold costs versus material costs, that sort of thing. And the nice thing is with Moldflow Adviser, it's the only Moldflow product that does this. So if you have Insight or Synergy as well, you'll have to go to Advisor to actually find these costs out. And a lot of people use these as an Excel sheet on their own calculation methods, but we decided to incorporate it within Moldflow Adviser just to have it there on hand. And the other thing is, if you're not sure if you want to run it, you can always set these up after the analysis has run. So with that, Javier, do you have your screen up to maybe run through a couple of those results?
Yes, we could do it, yeah, sure. So let me share my screen. Yes. Could you see my screen?
Now we can. Yep.
Yes? Okay,
yes.
So I prepared for this small demo also a multi-cavity mold, so I use it also a part which is located in this tutorial folder that you were talking about. In this case, I created a non-symmetrical 4-cavity mold, so we have here this running system. I was modeling with the tools you were talking about in geometry, so just running through this ribbon panel and just selecting the different options, so I didn't use the each file. And in this case, I was using a very thick, let's say like this, running system, because I wanted to compare later on with a second version of this multi-cavity system to see how much expensive or cheaper are the production of these two systems. Just before to go there, as you were saying, so we have a bunch of plots that we could run when we are running this kind of simulation of multi-cavity. So we have here in results the possibility of animating how the material is going in the different cavities of this mold. We could just go through different time steps and comparing well, how much material is filling after, let's say, 1 second. Or we could just go to the properties here, right-click on every plot, and we could just, as you say, go through the different tabs. We could just select if we want shaded surfaces, curves, which are defining the different values. We could limit the animations. We could just trim the scaling, so not to take the complete filling time, but just at the beginning, things like that. So we have here a bunch of possibilities we could use for every different plot. So also, as you were saying, so we could split our screen, and we could link somehow the both screens, the 4 different studies we are doing, so that we could just rotate, we could zoom, we could do different things in order to take a look on special points in both cases at the same time. So we could also link the visualization. So if we just run this, we will see how for the different runnings, so in the same time step in this case, we see how here we already fill much of the running system, and is this because this running system is thinner and this is thicker, so I need more material to fill up this running system, and that means that I will need more time to fill the whole cavity. So just running it, I could just change the view. I could do all these things on the same live. We could support all these things. We could create some automatic reports. We could also take a look on the summary, as you said. So here in the general tab of the summary, we have the name of the geometric model we introduced here, so which was the level of accuracy for the mesh, the material we selected, in this case the default polypropylene. As this is multi-cavity, so the dimensions I selected, I just switch it off the visibility of my plates, but they are there, so actually we could just switch it on in view object. What was so
yeah, so it's whenever you have a result on, it will hide it. Yep.
Yeah. Okay.
So if you just deselect the fill time, it should be able to view that. There we go. So
here are the 2 plates I defined it, so we could see that in the summary. So which were the sizes I gave in this kind, in this demo. I just rounded the values. I'm using millimeters. I'm sitting in Europe, so no chance for inches. So the thickness for the different plates, the running system, which were the different elements, because as you say, we could make also run an optimization on this running system. The results of the filling, because in this case I just run a fill analysis. That's very interesting trick, which actually not so much people know. If we click on the fill with the right button of the mouse, we could convert this in a 3D mesh. This is something much of the people think once we import the geometry and we select dual domain, that's over. We could not change it. Yes, we could, but differently, because much of us are used to work with inside, that we go directly on the mold and we change it here. For advisories actually on the simulation we are running, and this is a little bit high from what we will expect, like the normal place to change this, but it's there and we could do it. And yeah, so the clamp force, and so a summary of which is the fill time, estimated pack and cool, and mold opening time, which by default is always fixed to 5 seconds. And as you said, we have here in Advisor something which is not in inside, this cost advisor. So if we go, I already introduced some values, but let's go through a little bit. So from the different windows we have in this advisor. So first of all, he's asking us for the volumes of the cavities and the running system we are running. And that's one of the main advantages of Advisor. So Moldflow knows exactly which is the volume of our running system. And we could take advantage of this, just leave it like this and go forward. We could establish how many shots, and that's very important, is how many shots, not how many parts, because in this case we are a 4-cavity mold. That means we are willing to produce 40,000 parts. Then in this case, I just roughly estimate the price of 1 kilo of polypropylene. As you probably know, this is very related to the price of the oil, so probably this makes no sense. I have no experience anymore with the prices of materials. I just define it $3.5, and that's also very important because we could also define the currency we are running in this cost advisor. So if we go, I just close this. If we go to the standard options of advisor, so we have here in currency, in general, we have different currencies. Well, we could support this in the PowerPoint, so probably it's not that important, but we could change it. And just summarizing with this cost advisor, so we go through some material. We could use the volume of the runner to just get this estimated scrap rate. We could, of course, change it manually. We could just update some of the parameters if we know better than Moldflow. Yeah, so how much it costs the production of one mold, if we have some maintenance cost, and we have here a bunch of information. I don't want to go so in detail for all of them, even if we have some people working after that to just take these parts from the running system or whatever. So whatever we know, we could introduce it, and we could compare this between different simulations, and that's what I wanted to show you here. So this mold is both 4 cavities. The only difference is the size of the running system, and what we could see here at the bottom is that the prices are different, and that's the main idea which is behind this tool, so that we could compare quite easily if one part will be cheaper than the other because we made a smaller running system, if we made a combination of hot running system with a cool running system. This kind of question, what if, we could answer right directly here in Advisor. And I think that's it. So if you want to take from this point.
All right, thanks, Javier. While you have that cost advisor up, there was a question in here about cost advisor. Is it possible to copy cost information and paste into another study?
Yeah, actually, this cost information is related to the study. If we just delete the geometry and import another geometry, this information will be there. If we duplicate an already existing study, this information will be just duplicated in the second study. You only need to run here there is one tab which is saying use running volume. So we click here to just update with the current model. So because it will be smaller. If not, this will be just bring it from our original study. We have some places, I think there is another one. No. Here will be in any case update by default, and this one we should type it by ourselves. So if we go to the cost advisor on the second study, and we go, you see here is 7.6 cubic centimeters, while in the previous one was something like 16, if I don't say wrong, 12. Yeah, and I didn't make anything, just the Moldflow update this information. But in the case for here, for the scrap rates, we need to update it if we want to get the last information. But yes, we could somehow copy paste this information from one study to another.
Okay, great, thanks.
You're welcome.
All right. I don't see any other questions related to the cost advisor right now. So what I'll do is I'll switch back to my screen. So let's do that. Okay, so as I mentioned way back at the beginning of the presentation, we did cover a couple tips and tricks. So I just wanted to have a list here just to reference in the future if you're ever looking back at this. So we went through how to study, or one thing actually we didn't go through that I can pull up here for you. Let's do this. Is the study notes. So whenever you're in the general user interface of Advisor, if you go up to the view your user interface, and then notes, it'll pop up with a section here for study notes. So the study notes is based on this particular study. It'll only be present in this study. So you can list things like changed runner system. In Javier's case, he could write little notes like that, and volume less. And that way it's there for the future reference. If you're ever wondering, oh, that has a different name to it, what did I do to that? So you can go back, refer to this, and easily understand, oh, I made that change. Perfect. The other one is plot note. So if we go into an analysis that I had already completed here, just open up one of these results. You can type in some notes related to that result. So in this case, fill time. Fill is relatively even in here, so you can say filled evenly, something along those lines. And again, this would be as a reference in the future if you're sending this analysis off to anyone. It'll be nice to have those kind of reference notes listed here. And again, you can click the X here in the corner to exit out of it, or go back over to this user interface tab here and uncheck that notes.
Yes, Kristen, just one comment on these notes. What we are writing here for studies and plots, we could export it as well in this report wizard. So if we are typing, whatever we are typing here, we could use the standard report wizard, and we could select to add these notes on this in this report.
Right.
But what we could not do is split. I want this comment and I don't want this other comment. Whatever it is there, I could say I want the notes of this plot.
All or nothing.
Yes, and I think it's nice because if we are typing some notes and then we are preparing a PowerPoint, so we could just take it right away from our notes. Yeah,
that definitely saves a step there. It just prevents you from having to go in afterward and make any notes to that report. Thanks, Javier. All right, so let me do something I saw in here. Just as kind of a general thing, this is something we did add to the 2016 version. So if you are comparing different studies, so in this case, let me just pull up both of those here, use that tile option, get rid of that to free up some space. You can add the study title. So in here, that way if you're creating a screenshot or something, it'll be right in that results or in that center workspace area. But I'll go ahead and switch back over to the PowerPoint now. And here are the other tips and tricks that we kind of mentioned. So changing the mesh type, right-clicking the analysis sequence as Javier showed. The part orientation is key, so use those tools. So either translate, rotate through the model, and those are all listed in that geometry tab as well. The defaults is something that we didn't cover either yet. That's something I can pull up again real quickly for you. And this is typically recommended whenever you're importing runner systems. Basically, what it is if you go over to that geometry tab and click defaults, you can change the default settings for any of these settings here. So if you're importing a runner system, it will apply that default size to the whole runner system. If you have a set size for the majority of it, it's easier to change this prior to importing, and then you can go in and manually change any remaining segments that might be a different size. And we mentioned sequencing through gates, so basically it automatically jumps to the next gate whenever you're sizing gates in Moldflow Adviser, and then using that snap to runner and snap to grid tool whenever you're manually creating runners or sprues or anything like that is also helpful. And again, using the coordinates, you can use the measure tool, which is basically just over here again. If you click on, pull that to that screen, any place in here you want to see how wide that part is, it'll show that distance listed there. And you can use that whenever you're creating that gate, kind of center it, or the injection point, and center it within that gate there. And just as a summary page, so we reviewed the results to running an analysis in Adviser, demonstrated how to actually build your study in it, and guided you how to step through the analysis wizard to customize it to your specific needs, how you're going to set it up at the press. We also discussed how to interpret the results and included some tips and tricks throughout the way. And with that, I'll take another look at the questions here. I don't know, Javier, do you see any other questions come in that you would like to bring up? Sounds like he's trying to get on. Okay, hi,
There's
Paul.
only one on valve gates in Adviser, which currently isn't possible, and I don't know if it's going to be available in the short term in the future.
Okay. Yeah, that's something that could be brought up. I'm not sure if there is a post already, but if you actually go to the forums for Moldflow, we have an idea station. So you can search in there, see if there's already a request for it, or you can also post it yourself that way. And that way the developers kind of see that and can reply to it kind of firsthand instead of just having it at the back of your head as an idea. But okay, looks like no other questions here. Anyone else have anything to add before we wrap up? Nope. Okay. All right. Well, as we mentioned earlier, we will provide this whole presentation on our YouTube channel, but we're also providing the slide deck itself to download via the website listed below, autodesk.box.com/moldflow14. And that way you'll have the presentation for future reference. And we'll also include a few notes there just on the demos that we went through as well. And again, thank you for joining us today, and we hope to see you next time. Bye.
Ciao.